We use the web every single day. But have you ever stopped to think about how it's built? What if its core design is actually kind of fragile? What if the very way we get all our information has this one big flaw? A flaw that we could actually fix? Well, let's explore a pretty radical idea for a better web.
Yeah, of course you have. We all have, right? But here's the thing. That 404 not found message, it's not just some random glitch. It's actually a crack in the very foundation of the internet. It's a symptom of a much, much deeper problem with how the web is built. So why does that 404 error even happen? Well, it's because the web we use today is all about location. Your browser is basically asking, hey, where is this file located? Think of it like this. You're in a library, and you're looking for a book using its specific shelf number. If someone moves that book to a different shelf, that address is totally useless, right? The link is broken forever. Okay, so this is where things get really interesting. There's this system called IPFS that stands for the InterPlanetary File System, and it just flips that entire model on its head. It stops asking where is the file, and instead it starts asking what is the file. See the difference? This shift from location-based to what's called content-based addressing, well, it changes absolutely everything. So how does that even work? Well, here's the magic. IPFS takes every single piece of content and runs it through a process that creates a totally unique code, a cryptographic hash. The best way to think about it is like a one-of-a-kind digital fingerprint. And this fingerprint is generated from the content itself. So if you change even one tiny pixel in an image, boom, the whole fingerprint changes. And what that means is you can just ask the entire network, hey, does anyone have the file with this specific fingerprint? And you are guaranteed to get the exact untampered file you wanted, no matter where it comes from. So, when you build a web on this new foundation, this idea of what instead of where, you start to get some incredible new benefits. Let's dig into the 3 big ones that make this new web so powerful. Okay, first up, it's open. Your data isn't just locked away on some company's servers anymore. Instead, it's shared across this huge peer-to-peer network where people participate. Second, it's verifiable. Remember that digital fingerprint we just talked about? That means you can mathematically prove that the file you just got is the real deal, the original version, no fakes. And finally, it's resilient. Because the content can be stored on literally thousands of computers all over the world, there's no single server you can just shut down. It makes the whole system incredibly tough. All right, so that all sounds pretty great in theory, right? But what does it actually mean in the real world? Like, what can you build with this stuff? Well, turns out the possibilities are pretty staggering. Let's jump into a few examples. Okay, one of the biggest and most powerful uses is protecting information. It's simple, really. When your data isn't tied to one single physical server, it becomes way, way harder for anyone to block it or take it down. And this isn't just a theory. A few years ago, when the government in Turkey blocked access to Wikipedia, someone put a full copy of the site onto IPFS. And because the network is totally distributed, there was no central server for them to block. Just like that, this vital source of information was back online for millions of people. Pretty amazing. All right, let's switch gears completely. From protecting knowledge to video games. I mean, for gamers, fast load times and quick downloads are everything, right? It's the difference between a good experience and a frustrating one. And believe it or not, IPFS has a really fascinating solution here too. So there's this company, 3S Studios, and they built an IPFS plugin for their game. It uses the network to get rid of duplicate data and pulls files from lots of different people at once instead of just one server. The result? They shrunk their game's content size from a massive 2 gigabytes down to just 40 megabytes. Yeah, you heard that right. For gamers, that means crazy fast downloads and a way, way smoother experience. Okay, what about the creator economy? You hear a lot about NFTs, right? Proving you own a piece of digital art is one thing, but making sure the art itself, the actual JPG or the video file, doesn't just disappear, that's a huge challenge. I mean, imagine a broken link to your masterpiece. A total nightmare. And this quote from the artist Nancy Baker Cahill really nails it. She talks about the relief of knowing her work is stored in one place and that it's resilient. By using IPFS for her art, she gets that peace of mind. Her work has a permanent, provable home that doesn't just rely on some random company's server staying online forever. All right, let's tackle another big area, governance. Specifically, something called DAOs, or Decentralized Autonomous Organizations. These are basically groups run by their communities online. But for any of that to work, you need to have absolute trust in things like voting. All the proposals, all the votes, that data has to be public, and you have to know for sure that nobody's messed with it.
And this is exactly where IPFS becomes this crucial piece of the puzzle. There's a platform called Snapshot, and it uses IPFS to record all the voting data for, get this, more than 9,000 different Web3 projects. Because that data is content addressed, remember the unique fingerprint, it's verifiable and it's permanent. It creates this transparent foundation that this whole new world of governance is being built on. So think about it. We've gone from fighting censorship to speeding up video games to protecting art and enabling new forms of governance. The applications are already here, right now. But the vision, the big idea behind IPFS, it goes so much further.
You know, the real power of a project like this isn't just the code. It's the people. It's this huge global community. Developers, scientists, artists, you name it, all working together, open source, to build a better, stronger web.
And the scale is just mind-blowing. Right now, there are over 280,000 unique nodes. That's individual computers participating in this network. And every single time a new person joins, the entire network gets a little bit stronger, a little more resilient for everyone. So what are all these computers sharing? A truly staggering amount of information. Over 1 billion unique content identifiers, or CIDs, have been published. And remember, a CID is that unique digital fingerprint for a piece of data. So we're talking about more than 1 billion different files, websites, and datasets. And every single one has its own permanent, verifiable address.
So at the end of the day, this is about way more than just fixing those annoying 404 errors. This is about completely reimagining how we organize and share information. It's about building a web that's actually ready for whatever comes next.
Even if what's next is literally out of this world. Yeah, I am not kidding. That interplanetary part of the name, it's not just for show. Aerospace giant Lockheed Martin is literally launching an IPFS node into orbit. They want to test how a decentralized content address network could make communicating between, say, Earth and Mars more efficient and reliable than the systems we have now. It's incredible. So the building blocks are here. A web that's more open, that's verifiable, that's resilient. People are using them right now to solve huge problems on Earth, and they're even planning for a future in space. So the only real question left is, what will you build?